There you go. Hello, everyone. We welcome to the community call. And as I was saying, we have a really special call today with some really cool stuff that we plan to show you. First, just some very little announcement, not announcement, update before. So we give them some time for people to join. Well, we just came back from the Trio cool conference. With, some days, first day was okay, second day was quite good. We also had a Kleros event at the conference, which was really great. We have a recording of that event. We need to edit it. And if some of you guys do video editing and you want to earn some bounty for editing that conference video, you can contact us, and yeah, we can arrange it. Feel free to reach to us for that. We have the crude recording, and we want to have the edited version. That's on the one side. Before you ask, the rewards are going to be distributed very soon. If they haven't been distributed yet, there was some delay because of community team members traveling to conferences, and well, I'm not going to get very detailed about our OPSEC practices, but that was the reason for the delay. So this should be resolved in the few hours coming, or maybe it's already done. Sorry about the delay. Another little piece of announcement is that we have selected UBI for the incubator. So it's Nacho there. So congratulations. Maybe you want to say some little words or not, whatever. Yeah, like 20 seconds, Nacho.
Hello, can you listen to me?
Yeah.
Hey, thank you very much. Yeah, we are so excited to be approved by the Kleros Incubator program, and we're happy to be there in no time. So thank you to all Kleros team. Thank you, Federico. Thank you to Clement and all the developers that have been helping us toward this path in these 9 months of pure developing and community engagement.
Congrats, Nacho. This is just the beginning of this road. Looking forward to seeing you in Lisbon very soon. The incubation program is going to start in early May. We are also still open to applications. We have a bunch of other teams that we are interviewing. If you want to apply for the incubator, feel free to fill the form. It's still open. So that on the incubator side. Then there's going to be members of the team in the Amsterdam conference. What was the name of the conference? I don't remember the name of the conference, but it's going to be happening in Amsterdam.
DevConnect.
DevConnect, there you go. So if you're going to DevConnect, you can connect to the devs of Kleros who are going to be there. George is going to be there. Green, I think, as well, and others. So feel free to come and say hi. And let's get to what matters, what is building. So as you know, we launched our very first version of the Kurt in 2018. It was like a pre-alpha version with the Doges on trial pilot we did. That Kurt had a lot of limitations, but was the first launch and first release, and it was great for testing the crypto economics of Kleros. And then we launched the current version of the Kurt that is now, working currently in 2018 during the ETHCC. Lots of things have happened since that moment. That was basically the blockchain prehistory, let's say. So as you know, a very important project for us is the development of what we call Kleros 2.0. just a core that is better, cheaper, faster, and will enable a number of new use cases that we are all really excited about in NFTs, content moderation, and all of the other things that we mention very often. This is the result of lots of research, starting from William, from new incentive mechanisms, from new research on voting, I'm really, really excited and really, really happy to finally being able to show you what we have built. This is what they're going to see is a very early stage pre-alpha version. It's like I don't want to get into this because this will be explained later in detail. But I'm super excited about this. I will just let JB take this and show you this. We're really, really excited. It's a big day for Kleros, and the NFT from this day, I hope it's going to be a really valuable one in the future. That's it from my end for today. So JB, so the stage is yours, and I will let you show what we are building.
All right. Thank you for the introduction today. So, all right, I'll share my screen. All right. Can you see my screen?
Yes.
All right. So, yes, as you said, it's Kleros 2.0. It's a big project, and there's a whole team of people working on it, working on research, design, implementation. We are very much in the middle of it, so we are calling it a pre-alpha version because it's not feature complete, and it's still a fairly technical version. It's not super user friendly or anything. So, okay, so why Kleros 2.0? So as Federico was saying, Kleros 1.0, which is live today, has been deployed in March 2019. That's over 3 years ago, which is an eternity in crypto years. At that time, the gas was sub 10 Gwei every day. Now it's usually well over 100 Gweis, which has priced out many interesting use cases for Kleros, use cases with a high volume of low value disputes, for example. And also 3 years later, there's been work done on new mechanism designs. Many of them are mentioned in the yellow paper, new models for crowdfunding appeals, aggregating the votes, among other things. So with that in mind, the scope for V2 is to be cross-chain from day one. We want to have the court on a cheaper chain, yet a secure one. Well, at the same time, we still need to support the existing integrations on Ethereum mainnet. So we need to have some kind of cross-chain interoperability. We want V2.0 to be modular, so that we are able to launch, to release new features as they become available without necessarily impacting the entire system. Fork friendliness, we know that it's important for the protocol to be easily forkable. We knew it already for V1, but we think that it should be actively facilitated. So that's in the scope. The PNK token in V1 is based on a piece of code which was probably the best one out there at the time. It's the mini-me token from the Givers team. It's got lots of features, but it turns out it's expensive to use. It's expensive to interact with the token. So for V2 on the home chain, we'll just use a very minimalistic implementation of the token. Draw of fraud protection is also a major concern, and there has been blog posts about it. We want to be able to take actions against jurors suspected of accepting bribes, colluding, or maybe revealing their votes too early when there is commit reveal scheme. Then we have evidence spam protection. That's something that was sort of taken care of on Ethereum because of the high gas fee that actually acts as a spam protection. Actually, it's not just a Kleros thing. I think it's works for lots of protocols. They have way less low quality transactions because of the fees. But as the transactions will become very cheap on the rollups, and we could see a lot of spam, especially for evidence. So we are working on some kind of protection, which is it's also sort of a dog fooding because we also it's a form of content moderation actually. So it's interesting to experiment with that. And of course, we want to have a more beautiful user interface, which I want to show you. I think you may have seen it in other places. That's designed by Plinio. That will be the final end user interface when we launch in the summer. But I want to say this is not what you're going to see today. So as you can see, this new user interface has more information displayed. There are more gamification elements. For example, the juror page is showing some of the performance. There are different views for the cases. There's a detailed view of a case. The evidence which have been submitted, and the voting screen. You can see the general court description, some parameters. And yeah, so now, all right, I hope I'm not moving too fast. Okay, now we are getting a bit technical. Okay, I'll annotate this. All right, so the architecture at a very high level is sort of split into two areas. On the left side, you can see what we call the home chain, which is a layer 2 rollup, where the court is hosted. And on the opposite side is what we call a foreign chain, as opposed to the home chain. But even though we could have many foreign chains, at launch, there will be at least Ethereum as a foreign chain to support the existing integrations that you can see on the right with Proof of Humanity and all the other products. And there might be other foreign chains like the Gnosis chain, etc. So you can see that the jurors will now only interact with the home chain, with the rollup, which will make those interactions cheaper. And same thing for the appeals. And now the court has been sort of, the responsibilities of the court have been split into two components. On the one hand, there is the core arbitrator, and there is the dispute kit. Actually, it's more than one dispute kit. It's going to be a one-to-many relationship. And as we ship more features, there will be additional dispute kits deployed. And they will be activated for specific subcourts. And that will all go through governance. So at a high level, the core arbitrator is responsible for managing the stakes, managing the subcourts. And the dispute kits they're providing a kit of features. So at launch for V2 initially, we'll provide the default features, the existing features of V1. For example, the vote aggregation is following, I believe, the plurality voting model. And the drawing of the jurors is PNK weighted, etc. The dispute kit is also responsible for the crowdfunding model of the funding of the appeal rounds, crowdfunding of the appeal rounds, and the counting of the votes, as I was saying. So, for example, if we are going to ship we could ship a one human, one vote dispute kit that implements this new juror drawing system. So that would be, we could call it Sybil resistant, for example, dispute kit. All right, so today the flow that we are going to look at for the demo is the creation of a dispute from the right hand side through a very generic arbitrable contract, and that dispute will hit what we call the foreign gateway. The foreign gateway is responsible for the interoperability with other chains. And for now, let's say it's a black box, and it somehow gets this message across to the home gateway, passes on the dispute to the court. And then from here, it's sort of as usual. We draw some jurors, the jurors will vote, possibly appeal, will execute the ruling, and then the ruling comes back the opposite way through the home gateway, somehow comes back to the original arbitrable. So this is quite a black box at this point, and I'm going to drill down into it a little bit. So I'll just say that at this point, these gateways are components which are very much specific to Kleros. They handle disputes, for example. But the components inside the bridge, they are application protocol agnostic. They don't know what a Kleros dispute is. They just deal with messages. All right, I'll just clear this. So during the design of the architecture, 3 types of bridges have emerged as the most relevant for very specific interactions of the Kleros protocol. And maybe I'll start with what we call the simple bridge. Maybe we could call it an unsafe bridge or a naive bridge. It's actually barely a bridge. So can I get this? Yeah, okay. So the simple bridge is actually barely providing any security. It's we are using it to create disputes. So let's say the disputes are coming from Ethereum, and we want them to be relayed on the home chain, which for the purpose of the demo is Arbitrum. We'll just signal with an event that, hey, there is this message there's this message that needs to be relayed to the other side, and someone can just observe the event and call a function on the other side on the home chain to create the dispute. But it's completely trustless. Anyone can actually call the function on the other side on the home chain with any parameters for the dispute. Actually, the security of this is delegated to the application and not to the bridge. So actually, the only important thing here is that I'll just move on to the other slide. Right. So the only way that this is secure, okay, let's say what could happen in the worst case. I get the pen again. Right. So with this simple bridge, we have a dispute coming in from here, and we want to have it relayed on the other side. But really anyone can just relay whatever disputes they want on this side. The thing is, we are relying on the security of the Kleros protocol, because someone who wants to do that have to pay some dispute fees. So what's the worst that could happen? It's actually a good thing, it's desirable. We want to have more disputes if people are willing to pay some fees. So what's the really only thing we need to care about is whether we can distinguish those disputes from maybe a dispute that's originating from Ethereum, or whether that's a dispute that's arbitrary. So what we do is just we fingerprint the details of the dispute, which is a hash. And this dispute hash is part of the message all along. And whenever the dispute in question is resolved and comes back to the other side, if the foreign gateway is not aware of this dispute hash, it just drops it. It just ignores it, and the ruling will not be relayed any further. However, if it knows that, oh, actually this dispute matches this signature, I know this signature because I've seen it before, and I know it was coming from this arbitrable, then I will forward it. So for this particular interaction of the Kleros protocol, this unsafe bridge is actually kind of safe because of the application protocol, not because of the naive bridge itself. Now, if I just come back to the previous slide. So now I'll look at the ruling messages, and for bridging the ruling message, we came up with a fast bridge, which is described at a high level in the yellow paper. Excuse me. And it's actually an optimistic fraud-proof game, very similar to the rollup, to the optimistic rollup itself, where when we are on one side when we are on the home chain, and there's a ruling coming in, we need it to go across the bridge. We don't want to use the canonical bridge provided by, let's say, Arbitrum, because it's slow and expensive when we are in that direction on the way out of the rollup. And okay, that's actually the safe bridge, which is our abstraction for the canonical bridge. So what we want is, as much as possible, to use the fast bridge. So the fast bridge allows anyone to participate in the functioning of the bridge, to make a claim on Ethereum that yes, the state of this ruling is this, and from there there's a challenge period that starts, and if no one disputes it, then we optimistically consider that it's correct, and it can be relayed further. And that would be the optimistic path. But if during that challenge period someone says, hey, no, this is not the state of the ruling on the opposite side of the bridge, then we fall back on the canonical bridge. So in that case, we incur the delay and the costs of that bridge. So moving on. So yeah. So that's what this diagram is saying, basically. There's a bit more to it than that. We're actually batching the ruling messages. There's a deposit that needs to be provided to make a claim, and then when we fall back onto the fast bridge, when we fall back onto the safe bridge, oh, that's not correct. It should be a safe bridge. Well, it's correct. When we resolve the messages, then we know who was right, whether it was the challenger or the bridger, and someone gets slashed and the other gets rewarded. And so we can imagine that the participant in these bridges, they are people who are incentivized in seeing the dispute resolved. So it's very likely that there are people in the Kleros ecosystem who may be interested in operating the bridge, but there are also possibilities for further incentivizing participants by having bounties, for example, to reward those participants in the bridging process. And that's something that would be configurable and decided via governance. All right, so today's demo. All right, as I was saying, we are not going to show the final end user interface. We are going to show a very primitive technical interface. Yet it's still kind of pretty because it's implementing the very new Kleros the design system, which is going to be used extensively now in other web applications. And our developer Alesh has implemented it into a library and it's the first time we are actually using this library. All right, so what we are going to see is very much the on-chain layer, because that's where our development process starts. We start by implementing the smart contracts, and then later we add the other layers like the subgraph, the SDK, the bots, because this can more easily be modified later. We are going to see, compared to V1, the delegation of the responsibilities, arbitration responsibilities between core and dispute kit. We'll see the optimistic fast bridging, and we'll see a deployment on a roll-up testnet, which is Arbitrum in this case, and Rinkeby. However, we won't see today the unhappy path with a challenge or batching. The scenario for today is a question that is answered by Alice, Bob, or Charlie. For example, Alice has sold the NFT redeemable for a physical pair of alpaca socks to Bob using Charlie's marketplace. Bob redeemed his NFT, but has never received his socks. Based on the evidence available, who is right? So we have a user interface which is deployed here, and that's the one for the demo, which is very technical and very really modeled on the smart contracts. However, we are not going to use it directly for the demo today because it's a bit slow at indexing and refreshing on the testnets. So what we've done is yesterday we've recorded it and cut away the refresh of the UI and indexing, execution of the transaction and indexing. So okay, what we can see here, we have a MetaMask with 3 accounts. The first one is called the deployer account, is used for anything but voting, pretty much. And the other two, Juror 1 and 2, will be used for voting, and they are already staked on the court. All right, so we are going to require 7 jurors. And it's costing 0.07 ETH. we can see there's going to be a new local dispute ID number 24 showing up here at some point, and it's exactly the sort of thing that is cut away later. It's this sort of delay. You see, it's quite slow to index. All right, so here we should see, okay, local dispute ID, but 24, this is the hash, this is the fingerprint of the dispute I was mentioning earlier. And we will find this 33B further. And okay, so the dispute, let's go back a little bit. The dispute has been created at the arbitrable level, and it went through the foreign gateway, the L1 gateway. And now it's just sitting there, and we need to get this dispute creation across. So that's where we are using the unsafe simple bridge that requires an interaction now with the rollup. So we are switching the network, switching to arbitrum Ringaby. It's done, so we can now relay. And what's happening here also is that we can see that the relayer who is participating in this simple bridge is also financing the dispute creation. So here is actually paying from his own ETH on Arbitrum, which is the same amount as the dispute fees on the foreign chain. And later down the road, when the dispute is resolved and the ruling comes back to Ethereum, this relayer will be able to withdraw to be reimbursed. Right. So okay, it's relayed. So now we are waiting for the dispute hash to show. It should show a 33 something. Okay, so it's showing up here now. So we have the same dispute hash, but on the rollup now, on the home chain. Right, so now we are looking at the court. We can see at the bottom there, there are 4 jurors staked in the court. The last 2 are from previous experiments. So we'll only focus on the top 2. And we can see that there is someone staked with 8,000 PNK, someone with 2,600. And our dispute at the top, number 25, is in evidence period. So maybe it's a good time to submit an evidence. This is very simplistic because in reality, we would probably submit an IPFS URL. But here we are directly submitting on-chain the text of the evidence. All right, so now we can draw the jurors. So once the jurors are drawn, we'll see some PNK locked, the first 2 lines. Okay, so it's it costs 200 PNK per juror. We've requested 7 votes, so it's 1,400. First juror will vote with 1,000 PNK of voting power, and the second one with 400. It's really it's not great because of course the top one will win, but this is really just for testing. So okay, we are now moving from the evidence period to the voting period, which is, so this is a technical task, and this is absolutely not something that the jurors have to be concerned with. Usually it's handled by some automation bots, and we just haven't implemented the bots yet for Kleros 2.0. But actually, if anyone really wants to call these functions, they can. It's completely permissionless. It just costs ETH. But yeah, because we still need to do it by hand at this stage. So, it went a bit fast just now. So I've actually here switched my MetaMask account to drawer number 1. So we can see it's E6D something. Yeah, that's E6D. And he can vote on dispute 25, and he decides to vote for Charlie with his 1000 PNK. All right, so now we can do the same with the drawer number 2. And he decides to vote for Alice with his 400 PNK locked. You can see actually that the interaction is with the dispute kit. Okay. So here, when I recorded the video, I actually skipped very quickly. Actually, the period usually would automatically move on to the appeal period when all the drawn jurors have voted. However, because I'm sending this past period transaction, it's actually directly skipping to the execution period, which in reality would not be possible because of some parameters. So we want to see the appeal period. So once the period is execution, it's final. The dispute is resolved. The rolling is final. It's number 3, which is Charlie. Charlie is right, and so in execution period, we can now proceed with this execution operation, which is again usually handled by the automation bots. And it's actually 2 transactions to be correct. The first one redistributes the tokens according to the voting coherence, and the second transaction will relay the rolling itself to the downstream contract. So in this case, the home gateway and the bridge. Okay, so we are going to call execute. There are 2 transactions. And we can see that the PNK has just been unlocked. And also this guy is losing his PNK, and the other guy is getting his PNK. The top drawer is getting the PNK, the 400 PNK of the other guy. All right, so now on the home chain, the dispute is resolved, but on the foreign chain, we still don't know anything about what the rolling is. So we need to fast bridge it. And to fast bridge it, we need to make a claim about the state of the rolling on Ethereum. So we need to switch the network. Again, this is going to be automated, and the participants in the fast bridging operations will just run a program that will do it automatically. Okay, so you can see now the claim transaction has gone through, and now there is a countdown for this demo. It was a 2 minutes countdown. During these 2 minutes, someone could challenge it, and you are fast forwarding. There hasn't been any challenge, and that means we can relay this rolling. And we can see it hasn't been rolled yet because the foreign gateway hasn't received the message just yet. So now we are waiting for the transaction to be executed. It's at the arbitrable level, the dispute ID is number 16, which is different on the other contracts. And we will see that, okay, the rolling has just changed from don't know to 3, which is Charlie. And also we'll see that the foreign gateways is going to update. Now it is now saying that it's rolled, and we had this relayer participating in the bridging. So at this point, the arbitrable has received the rolling. Now we just need to tidy up a few things with regard to the participant with in the bridge. So the person making the claim on the fast bridge has posted a deposit of 0.1 ETH before, and now they need to get it back because they haven't been challenged. Actually, anyone could call the reimburse function because the contract knows who has made the claim, so only that person will receive it. Will receive the 0.1 ETH. We can see here that 0.1 ETH was transferred to F50. And now we have another relayer who is waiting for his ETH. And the relayer who had financed the dispute on the home chain and is receiving back 0.07 ETH on Ethereum. And that's it. Right, so I'll just show a few numbers for the interactions that are the most important for the jurors and also for the creation of the dispute. So we can see when we compare the transaction cost between V1 and V2, it's roughly it's a saving of roughly between 5 to 10x. Even though it's not feature complete, but it's not optimized, and the cost of transactions on the rollups are still going to definitely go down for at least 3 reasons. Number one, with the adoption of the rollups, the costs are mutualized between the users whenever there is a block that is returned to Ethereum. And number one. Number two, for example, in the case of Arbitrum, they are still tweaking their technology, and they are about, for example, to release Nitro. And yeah, they are also progressively, tweaking the parameters to make it cheaper. And then the third reason for being optimistic about for the cost savings is EIP, I believe 4484, which is at the protocol level on Ethereum, going to make some operations cheaper, specifically for rollups. So yeah, we assumed 50 Gwei on Ethereum, 1 Gwei on Arbitrum. I think the ratio is probably somewhat constant. It doesn't fluctuate too much on average. Maybe one interesting thing is the dispute creation, even though it doesn't include relaying and bridging, was 16x in those numbers. I suspect that's because this function, compared to the other function, is there's more operations, and in particular more storage operations. And I suspect these operations are cheaper on a rollup. in comparison, the other operations are smaller, and that makes the computations, I think, a bit relatively, the amount of computation relatively higher compared to the dispute question. Just a guess. And okay, what's coming up next? We are targeting a beta launch for this summer, and we will ship with feature parity with V1. So not necessarily any new fancy feature, but the code will be shipped under the new architecture on the rollup. So therefore delivering the cost savings that we are expecting. And there's still a lot of work ahead, a lot of testing and full stack implementation. And then at the end, the migration that we will need to coordinate, there will be a period of freeze of the V1 code, and then we'll figure out the process for everyone to unstake their PNK, bridge them, and restake on V2. And then finally, after that, Q3, Q4, and after, we will launch new features progressively. For example, one human, one vote, maybe as an additional dispute kit, the forking court, etc. Thank you very much for your time. And if you have any question, please you can ask now.
أعطيني الصورة هذه. هذه الصورة يطيحوا عليها. هذه يضحكون عليهم دائما الصورة. Any questions?
Any questions, guys? So that was amazing, JB. Congratulations.
Thank you.
Great job and great presentation. If you have any question, you can ask, or well, you can always reach to us on Telegram, Slack, and all of the other channels. Yeah, I will let you ask the questions you might have. Okay, well then, thank you for coming. We will soon upload the video so you can watch it again and digest all of this information. Also, the rewards are already live, so you can also obtain your rewards. Yeah, well, thank you all for coming, and see you soon, guys. Bye-bye.
Thank you, everyone. Bye-bye.
Bye.